Hello everyone, my name is Carl Marabas and today I will solve the volume of revolution with washer and disk. Number 1, we have yx squared plus 1 and y equals 0. This is the graph of number 1. The solution is integral of -1 and the upper is 1 and the closest parenthesis is minus x squared plus 1 over 2 dx. Now we have to expand the first and apply the sum rule to have the integral of 1 over -1 x to the power 4 dx. Then we have to apply the power rule and compute the boundaries. So we have 2 over 5. And then after the power rule, we have to take the constant and apply again the power rule and compute the boundaries. So we have 2 over 3. And then we have to simplify the 2 over 2 over 3. So we have 4 3. And we have to minus the 2 over 5 minus 4 over 3 plus 2. So we have to simplify. Then we have 16 over 15. Now we are number 2. Y equals 2x plus 2 and y equal x2 plus 2. Then this is the graph of number 2. Then this is the solution. So we have to integrate the sum term by term, factor out the constant, and then expanding the integrand of x squared plus 2 over 2 give us x4 plus 4 x2 plus 4. Then integrate the sum term by term and factor out the constants. After that, apply the fundamental theorem of calculus. The antiderivative of x4 is x5 over 5. Then evaluate the antiderivatives of the limit and subtract. So we have 32 negative 32 over 5. So and apply the fundamental theorem of calculus. The antiderivative of x squared is x cubed over 3. Then we have to evaluate the antiderivative at the limits of and subtract. And then apply the fundamental theorem of calculus. The derivative of 1 is x. And then we have to evaluate the derivative of limits and subtract. So we have -8. And then for the integrand of 2x plus 2 squared, substitute u equals 2x plus 2 and du is equal to 2 dx. This gives a new lower bond u equals 2 plus 2 times 0 equals to an upper bond u equals 2 plus 2 equals 6. And then apply the fundamental theorem of calculus. The antiderivative of u squared is u cubed plus over 3. Then we have to evaluate the derivatives, the limits, and subtract. So we have 104 over 3. So the final answer is 48 over 5. This is the last one, which is number 3. So y equals x square root of x plus 1 and y equals x squared plus 1. The axis is y equals -1. So this is the graph. And then we have to integrate the sum term by term factor out by the constant, and then expanding the integrand of x squared plus 2 over 2 given by 4x plus 4x squared plus 4, and then integrate the sum by term and factor out the constant. Lose the underderivative of x4 is x fifth over 5, and then evaluate the underderivative of the limit and subtract. So we have minus negative 1 over 5, and then we have to evaluate and subtract the limits again and subtract. So we have 23 and we have negative 23 over 15. Then apply the fundamental theorem of calculus, and the derivative of 1 is x. Then evaluate the derivative of the limits and subtract again. And for the integrand of square root of x plus 2 squared, substitute u equals square root of x and du equals 1 over 2 square root of x dx. Then we have give us a new lower bound, u equals square root of 0 equals 0, and upper bound is u equals square root of 1 equal 1. And then for this integrand of u and u plus x squared, substitute s equals u plus 2 and ds equals du. Then give us the lower bound is equals 2 plus 0 equals 2, and upper bound is equals 2 plus 1 equals 3. Then expand the integral of s minus 2 x squared, give us s cubed minus 2 s squared. Then we have to apply the fundamental theorem of calculus. The antiderivative of x cubed is 4 over 4, and then evaluate the derivative and the limits and subtract, and then apply the fundamental theorem of calculus. The derivative of x cubed is over 3, and evaluate the antiderivative of the limit and subtract. So we have 76 minus 76 over 3, and the final answer is 49 over 30.